What happened to Tapio? Okay. Sorry about that. Now, one of the students is chosen as random. Determine whether the events the student prefers walking and the student is at Amos College or Ben College are independent, justifying your answer. How do you do that? Determine whether they are independent, justifying your answer. So how do you prove it? Independent probabilities. Maxine, how do you think? You've been quiet today. So how do you prove that probabilities are what? Are independent? Be independent or they are not independent. Well, they're saying determine whether they are independent. So what we want to prove is what? Is probability of what? Probability of walking. Are we together? And so it's intersection. Huh? Amos or Ben College, like this. Are we together there? It makes sense? So how do you prove, Maxine, independent probabilities? How do you prove that if independent probabilities, for example, if you toss a coin, you get a head, the next time you want to toss again, it's independent. The occurrence of the first event of the previous does not affect. That's what we want to prove with independent probabilities. How do you prove that probabilities are independent? So if probabilities are independent, you need to know this. If I have events A, event A and B, if they are independent, it means the probability of B happening given A has happened is equal to what? The probability, look at this. We are saying A and B are different events. The probability of B happening given that A is happening, it has happened. Are you going to say this or what? No. Huh? So the probability of B is not affected by A. It means it's simply equal to what? To B. Clear now? If events are independent, the probability that B will happen given A has happened is simply equal to probability of B. Clear now? And the vice versa is true. Huh? The probability of A is happening given that B is happening is simply equal to what? To that. Huh? Clear now? Look at this. We said probability of A, sorry, let's use what I've just said. A, B given A has happened is equal to probability of B intersection A divided by probability of what? Probability of the given, which is what? Which is A, yeah? Are we together there? But look at this. I said the probability of this was equal to what? Was equal to B like this. Can you see that? So what it simply means is, if you look at this, probability of, if I pick the intersection, okay, maybe let me write it like this. If I pick probability of B intersection A, want to make this the subject of the formula, is equal to probability of B given A has happened multiplied by the probability of what? Of A. But what did I say there? Look at this. Let's equate now. So if we equate the probability of B given A has happened is simply equal to probability of B. So if what it simply means, if you want to write it down, is B intersection A is simply equal to probability of B, because we said B given A has happened is what? Is B. Multiply by probability of what? Of A. Are we together? Clear now? So now to go back to the question, Maxine, is that making sense or I need to repeat again? A.
Making sense.
Okay. So now it means probability of B intersection that is simply equal to probability of B times A. So it means from the question, what we simply want to prove, if there, it means the probability of walking, probability of in this intersection that. So you're saying H intersection A or B will be equal to probability of H multiplied by probability of what? A or B. Clear now? Make sense? Now, let's use our table to find this straight away from the table. Probability of hockey intersection Amos or Ben College. What is that? Probability of hockey intersection Amos or Ben College. Okay. So let me just go back. So what is that? Probability of hockey intersection Ben or Amos College. What will be the probability there? Probability of hockey intersection Ben or Amos. Huh? What would that be? Hockey is this. Huh? Ben intersection Ben or Amos. So what is that?
Is a 104 over 220.
Yes, 104 over 220, correctly. Okay, so this is 104 over 220. So now let's work with this now. Probability of hockey. What is probability of hockey? 220 over what? Over 500. Huh? Multiply by probability of A or B. So A or B, it will be what? A or B, Amos. So if we add this, it's Amos and what? What do you get there? 186 plus 86 plus 156, what do you get?
242.
242. Let's see. 242 over 500. Can you multiply there? What do you get from your calculator?
Zero 0.213.
0.213.
213.
Okay. 0.213. And this probability, what does it give you as a fraction? So you can tell that they are not mutually together. They are not independent. Because if they were independent, we were supposed to get the same answer. Clear, Maxine? How we prove that?
Sorry,
Yes.
I have a question, but it's not really related to this
Yes.
question. So when do you change the denominator? Like, I don't know how to change like when a question asks a certain thing, when do you change the denominator? Yeah, basically.
I'm confused by your question. What do you mean? Yes, we are saying.
Okay. So okay, go up to the table.
Yes. Probability
Okay.
table. Yes. Let's go back to the
So with the table, right?
Yes.
Like you see there's different totals for each like row and column.
Okay. I get
Yes.
you now. Maybe you don't maybe understand probability tables. Okay. Now let's explain slowly then. You're saying we are using different denominators. I get your question now. Now, if okay, let's do it slowly then. Now, if I want to say, for example, probability that I pick a student from Ben College, probability of picking a student from Ben College. How many students are there? 500. Huh? So that probability is simply 84 because I'm picking from 84 students over what? Over 500. But now if I say probability of, for example, picking a student from Ben College, given that the student plays hockey, okay, given he plays hockey. So the denominator changes. Why? Because we are picking from students that play hockey, not all students. Are we together? Question says, given he plays hockey. So how many students play hockey? 220. Are we together? And how many are from Ben College? 72. So it becomes 72 over 220. Can you see that?
Yes. Okay. Thank you.
Does that make sense?
Yes.
Okay. If we say, okay, let me give you another different scenario where we use the denominator as 86. If we say we want to pick, we pick maybe 2 students at random, okay. Let's say we pick 2 students one after another at random, and we want the probability that both students come from, let's say we are picking 2 students from random, and we want the probability that one of the students comes from, okay. Okay. Now, let's say we are picking from Amos College. We are picking students from Amos College, yeah? Clear? And we want the probability that when we pick 2 students, one plays, okay, or at least one plays soccer. At least one plays soccer. We are picking from Amos College. We want the probability that at least one plays soccer. So how many, if you are picking from Amos College, how many are we picking? 86.
86.
And we want the probability that at least one plays soccer. At least means one plays soccer. One does not play soccer, one plays soccer. Like this, if I'm picking like this. Or my first pick can be soccer, not soccer. Or, because it says at least all of them play what? Play soccer. Can you see that? Does that make sense to you?
Yes.
So in that case now, if I'm picking one that plays soccer, if I test that, how many play soccer there? 54 over what? 86. But if I've picked the first student now, it means I no longer have 86. I have 85 students left. Like this, altogether. Clear now?
Yes. Yes.
Then something like that. Okay, I was just showing it. That's not difficult. No.
Sir,
Yes, question?
based on what you just said,
Yes.
so why are we saying 104 over 220? Because you
Yes,
said
yes.
it's in the case that we are given that the student plays soccer,
Let's
but
go.
we're just finding, the student plays hockey,
is that this part that you're asking?
the ski part,
Yeah?
the
The 104 over 220, that's the one that you're asking. Is the probability of hockey intersection A or B? The probability of
but we're not selecting from just hockey. Aren't we selecting from all 500 students still?
which one?
In that
Okay.
question, since we're not given that the student who goes to Amos or Ben plays hockey,
No, it's an intersection.
aren't we still
It's
selecting
what's
from
common.
500?
It's what's common. We're not selecting from both. It's intersection. It's not union. It's what's common between hockey and those that go to Amos or Ben. Are we together? Intersection. Hockey, intersection. So if I say hockey, how many students do hockey? That's where it was coming from. Okay, to clear now. How many hockey? 220.
Okay, my point.
Yes, your question?
Okay, my question was coming from the fact that the math scheme says 104 over 500.
You mean on which part? You mean the probability?
The math scheme for this question,
Yes.
yes, says 104 over 500.
On
So isn't it 104 over the total number of students?
You mean on the first part, hockey? Okay, I get your point. You are saying students choosing hockey, given that, okay, we are saying those that play hockey, intersection those that play, okay, I get your point. You are saying what? We are picking from all the 500 students. That's your question, huh? Okay, divided
Yes.
by, oh, okay, I see your point. Yes, that's correct. Because we are picking from all the 500 students. That's very correct. I didn't say that. So it's 104 over what? Over 500. Okay, that was an error on my part. I would get that because we are picking from all the 500 students. Okay, clear now? Makes sense to you? So if any question comes in the exam, like what you're saying, what you need to remember, I've proved, you don't have to do all this. What you simply remember is to prove independent probability is that probability of A intersection this is always equal to this times that. Clear now? Is that times that. Why? We have proved that this times that, because he said this is equal to that. So it's A times B. So if we are given, that's how we prove it. We calculate A times B. So in this case, we have to calculate probability of hockey multiplied by probability of hockey or probability of A or B. Clear now? Make sense? Okay. Now, I think we need to do these more proving questions before the exam. Now, machine A and B produce metal rods of certain type. The lengths, okay, in meters of 19 rods produced by machine A and 19 rods produced, so there are 19 rods. Find the median and interquartile. So what do we do? Median for A, this is O level. Median is what? Is Q2. I'm sure you know that. Huh? Q2 is equal to N plus 1 divided by 2. How many? 19. Huh? So 19 plus 1 divided by 2 is the 10th. Clear? The 10th term. So let's go there. The 10th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is that? According to your key, it will be 0. What? 0.238.
8.
Are we together? Interquartile is equal to Q3 minus Q1. Now, if you check there, the Q1 is a values before this. We have how many values before this? Should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do the same. Huh? Q1 there will be equal in terms of that. So if it's 9, I'm sure you're saying 9 plus, so it's the 5th term. 9 plus 1 divided by 2. So the 5th term, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's this one there. So which means Q1 is equal to 0.231. Is that correct? Then Q3, we look at the upper range after this. So we want, so starting from 1, 2, 3, 4, 5. There. Clear now? Because we have 4 there before, we have 4 there. So that will be 0.1. 0.245. So now subtract 0.245 minus 0.231. What do you get? Click. What do you get? From our calculator.
0.014 meters.
0.014. And you get 3 marks for free. Now,
Sorry,
question?
I have a question.
Yes.
So one thing that always confuses me is
Yes.
like the repetitions. So when do I not count like the extra ones?
Repetitions, okay. As in
Yes.
this table. Okay, let's go back to our leaf diagram and see
Yes.
where your question are. Okay, and maybe I'm still trying to get your question. So, okay. So in terms of repetitions, you mean, for example, like this? Is that what you're talking about?
Yes.
Okay. Remember, we've got 19 rods, huh? And in 19 rods, we might have repetitions, like what you're saying. Huh?
Yeah.
So whenever we are finding median, interquartile, whatever, we simply count the numbers as there. But remember, there are 19. That's why I said Q1. Q2 is equal to 19 plus 1 divided by 2, so the 10th value. So you always count your repetitions. Just like if you're given
Okay.
a data or a table with all repetitions altogether, you have to, because these are, of course, they are repetitions, but because in terms of, remember, we are talking of frequency. We are counting how many we have altogether. So it means all those repetitions are involved. You have to count them altogether. So there is no,
Yes.
in calculating your median, your interquartile, your upper quartile, you always count everything altogether.
Okay. Yes. And then
Yes.
my other question is, when do we choose the number in between the two numbers? If you get what I'm trying to say.
Okay, I get your point. I'll explain.
Okay.
Maybe did you miss that from all level? Okay, so
No, it just confuses me a lot.
anyway, look at this. That's why we use
Yeah.
this formula. Let me okay. Can you see my whiteboard? Seems there's something funny is happening on my software. You can now see clearly. Huh?
Yes.
Now let's
Yes.
say we have these numbers. We have even numbers. When we have even numbers, for example, I have 2, 3, 7, 9, like this. Clear now. So if I use the same formula to say Q2, I just want to explain this because this is basic. Q2 is, we said, is equal to n plus 1 divided by 2. How many terms do we have here? 4, huh?
4.
So it means 4 plus 1 divided by 2. I'm doing this because you might get 150 terms and get confused. So now it means 2.5 term. Huh? Do you know what that means? It means the second term plus the third term divided by 2. So whenever so which means this plus that divided by 2. Clear now? When we have even numbers, when we have even numbers, we always add the 2 central numbers. Clear?
Yes.
Now it is given that for machine B, the median is 0.332, and the lower quartile is 0.224, and the upper quartile is that. Draw a box and whisker for what? For A and B. 3 marks, huh? I would say maybe do the B first. Of course, they're okay. What key can we use from those values? Maybe let's write down A. What was our median again? Who remembers the values? It was 0.238. Then Q1 was equal to 0.231. Q3 was equal to 0.245. Okay, like this. So my question, okay, let's go back. I just need to see. What is the lower value for A? What is the lower value for B? Lower value for A is 0.21.
0.22.
No, for A, lower value. Is it 0.22? Okay, correct.
Yes.
Nothing here. 0.22. And for B, 0.211. Okay, and the upper value is okay like this. So I'll do this. Lower value, upper value. So for A and for B. So for A, we said 0.22. For B, we said 0.21. 0.211. Is that correct? Okay. Then the upper value, 0.256. Then the upper value, 0.254. Now, my next question is that before we draw a box and fig whisker from A level, what should we check about the boundaries? What should we check first? We should check if they are not
Outliers.
outliers. How do you check that? What formula do you use for checking outlier boundaries first? So what formulas, do you remember the formula? For the lower boundary, what do you do? It's Q1
you
minus what?
multiply by 1.5.
Yes, Q1 minus 1.5 times interquartile range. Yeah? Then for the upper boundary, it's Q3 plus 1.5 times interquartile range. Clear now? So for A, let's do that quickly. What is the interquartile range for A? I think we calculated that in the previous question. Interquartile range for A,
0.014.
it was 0.01. 0.014, yes. 0.014, yes. 0.014. So now let's calculate first for A. A, what is the lower boundary there? 0.22. Huh? So I'm saying 0.22 minus 1.5. What? Sorry. What is Q1? We said Q1 minus. What is Q1 for A? Is this. Huh? So 0.231 minus 1.5 multiplied by 0.014. What do you get? What do you get quickly from your calculator? What do you get?
Minus 0.01777.
Minus 0. Which means this boundary is okay. Huh? Okay. Then let's do the same for the other one. So this is 0.245. Sorry. We never calculated Q1. Eh? Anyway, it's given. What is Q1? Is 0.24 minus 1.5 times. What is the interquartile range for B? Can you subtract upper quarter there minus lower quarter? What do you get? .243 there minus that. What do you get?
.019.
We're saying 0.011.
19.
Now
19.
19. So it's below this boundary here, which means this boundary, both boundaries are okay. Clear now? Now let's look at the upper boundaries. So Q3 is that, Q3 for this one here is that, okay? And for this is that. So 0.45 plus 1.5 times 0.014, as you said, for A. So what do you get? You get a value below our boundary or above our boundary? Upper for A. Q. Where did I get that Q3 for A there? Were we given the Q3? Yes, we were given the. So what do we get?
0.266.
0.266, which is above. Huh? Okay, that's fine. And okay, that's okay. So it seems as if all the values are okay. Now, for the last one, our Q3 is 0.243 plus 1.5 multiplied by Q3 or interquartile range. I'm not sure what did you get when you subtracted this. Lower quarter minus upper quarter. From your calculators, what did you get?
0.019.
0.011. So what do you get there when you multiply the
19.
19? Sorry, yes, I'm doing the wrong thing. I don't have a calculator. What do you get?
0.2715.
0.2715.
15.
Which is okay. So anyway, that's fine. We've proved that everything is fine. So now what's the key there that we are going to use if you're looking at this? Well, they didn't give you the key, huh? So you have to come up with a key there. Your lower is 0.1. I would say you pick the lower values of the two, which is 0.11. Then the highest there, which is 0.256. So what's the best key there? So that we draw everything on one. It will be 0. What? Table. So tell us what will be the best table there. So we are saying we are moving. The lower value is this. Work with the lowest value and the highest value, then pick a key. So all the way from 0.21, if I can pick it that way, to 0.25. 0.1, 2. Just need to see 10 boxes. 1, 2, 3, 4, 5. So can't we do a 0 point? Can this be 0.2 what? Then this 0.21. I just want to see if it works. 0.22, 0.23, 0.24, 0.25. Does it work? It works, huh? Cool. Make sense?
We also need to go 0.26.
0 point?
Since our values are in between 0.25 and 0.26.
Why is 0.26? I mean like this, there.
Yes.
Okay. Hi.
Hello.
Yeah. Yeah, and took lesson. All right, did about thanks. Okay, are we together there? Make sense, guys? Then we simply go to A there and we plot. Okay, maybe let's do that quickly. So what's the lower boundary for A? If you want to start with this, 0.22. 0.22. Okay, it's there. Okay, I'll plot it there. Then what is the lower, the Q1 for A? Q1 for A. What did you get? You don't remember? Q1 was 0.31. 0.31. 0.31 there. Then you see how easy that is. Q3 is 0.1. Then Q2 was the first one, 0.38. 0.38. Q1, 0.238. There. Q2. Then Q3 is in that 0.245, if I'm correct. Or maybe I'm wrong. Q3 was 0.245. 0.245. What is my 5? Okay, this is my Q3. Make sense? What is my upper boundary for A? Is the upper boundary the same? 0. Or it's 0.5. 0.54. 0.54. 0.54. 1, 2, 3, 4. Clear now? Of course, you use a ruler. Okay. Now we do the same for both. I think we need to compare them at the end. B, what is the lower value for B? 0.211. 0.211. Then what is the Q1 for B? We are given the lower quarter is 0.224. 0.224. Q1. Then Q2 is the median, 0.23, 0.232, 0.2312. Q2. Then Q3, 0.43. 0.43, 0.243, so 0.243, 1, 2, 1, 2, what happened? 1, 2, 3, Q3. Then the upper is 0.256, 256. Like this, clear? Now, hence make comparisons between the length of the rods produced by machine A and the length of the rods produced by machine B, 2 marks. So what are we going to say? Can we compare the two?
The rods produced by machine B have a wider range than rods produced by machine
This is machine B, this is machine A. So you're saying the rods produced by machine B have got a wider range.
Yes.
Yes, what else?
Most of the rods produced by machine A are bigger than rods produced by machine B. Oh, yeah.
So the length of the rods produced by A are longer than B. That's what you're saying. That's correct. Lengths produced by machine A are less spread out than lengths produced by what? By machine B. Okay, not difficult. So we are simply comparing central tendency. Now, trees in a radian forest are classified as tall, medium, or short, according to their heights. The heights can be modeled by what we were doing last week by a normal distribution with a mean of 40 and a standard deviation of 12. The trees with height of less than 25 meters are classified as short. Find the probability that a randomly that a randomly chosen tree is classified as short. So it's easier. It's probability of what? First, we can let X be the random, which follows normal distribution. What is the mean? 40. And what is the variance? 12 squared. Clear now. So we want the probability that X is less than, if it's short, they are less than what? 25. Which means we normalize this. Okay, because what you are simply saying is we have something like this. Our mean here is 40. Clear now. Or something like that. But it's not necessary. I'm just showing you this. And we want probability less than what? 25. Okay, that other side there. Make sense? Less than this. That's what we are talking about. Which you can normalize. So this probability of Z is less than 25 minus what? We said X minus mu over standard deviation. Minus 40 over, what is the standard deviation? 12, like this. What do you get from a calculator? Probability of Z being less than what?
Negative 1.25.
Negative 1.35. Okay. And we said 3?
1.25.
Sorry, I don't have a calculator. And we said we can't find negatives. So we do what? Symmetry. So this will be the same if the 25 was the other side here. Okay, if it was like this, this same. Are we together there? So it means 1 minus this. So it means this is as the same as, this is as the same as what? 1 minus probability Z is less than what? Z is less than, yes, less than positive 25. That's what we said, like this. Not 25. Z is less than, we found this. It will be a positive 1.25. Clear now? Remember, I'm talking of the normal distribution, so it will be a positive. There's 1 minus, you need to understand the symmetry there. Z is less than 1.25, which is phi, 1 minus phi of 1.25. Let's go and find from our table 1.25. Showed you yesterday, the other day, how to find that from the probability. Let's go and find
0.8944.
0.8. Are we agreeing with it there? It's easy. 0.9. You said 8,944. Like this. So what do you get when you subtract that?
0.1056.
Done. Clear? Okay.
1056.
Okay. 0.1056.
Yes, sir.
Okay, that's fine. Okay. One of the trees that is, okay, one of the trees are classified, okay, one of the trees are classified as tall or medium. Okay, 1/3 are tall. Okay, of the trees, oh, sorry about that, of the trees that are classified as tall or medium, of the trees, see keyword of the trees, we now know that the probability, like what we have found this, those are the ones that are shorter. So if they are saying of the trees that are classified, how many trees from this probability? We have a probability that less than 25 is this. Then we're saying of the trees. Show that the probability that a randomly chosen tree is what? Is tall. So of how many trees probability of tall or medium is simply equal to 1 minus probability of short. Do we agree? 1 minus probability of short gives us the probabilities of the remainder, which is tall or medium. Clear now? So it means 1 minus, we still get we go back to this answer, which is what? So it's simply 0.8944. But what are we saying of the 0.944? 1/3 are tall. So if 1/3 are tall, it's 1/3 multiplied by 0.8944. What do you get? Statistics there.
0.298.
0.298. Clear? No. Find the height for the trees that are classified as tall. Find the height. We know now that the probability of tall is 0.2. What did you say? 98. 0. What? Probability of 0.298. 298. Now it's like, remember, I want to find h, the height that will qualify that. So what do we do? We want to find the height. We are given the probability. Maxine, we are given. Yes.
Is this where we use the table in reverse?
Yes, because we are given the probability. We use the table in reverse to find that z value first. So let's find the z value. Maxine, using the reverse, like what you're doing, both this, we are given. Let's go and do that and find what you get from the table and answer and approximate there. What do we get? The table today, I don't have the table. Where is my table? Angela, yeah, I'm sure you were there last week when we were using the tables there. Can you now try to, so you go look for a column, look for that number, or maybe you need to add two numbers, 0.9298, or very close to 0.298. So what would that be? Remember, Z is given by, is always given by
wouldn't
X
it be
minus, sorry, yes. Wouldn't it be? Yes.
1 minus 0.298, because the table doesn't have.
It doesn't have 0.1.
It starts from 0.5.
It starts from 0.5. So what are you saying about probability of height? Yes. So you said 1 minus?
I said 1 minus 0.298.
You're saying the table doesn't give you that.
Yes, so the table only shows from, it starts from 0.5, so.
And so you're saying if you subtract, okay, I get your point. What are you suggesting? That if you subtract 1 minus.
If we subtract it, we will get 0.702, and then we can go and use that value of 0.702
If we subtract,
And
we are getting the probability of, that's the Z value for short. Yes, then?
Yeah.
and then using that, we can then go and use the table in reverse. Unless I'm incorrect, so.
The value on the table is 0.7019.
0.9?
The closest value.
For which value?
0.7019.
Yeah, but for which value? That's my question.
The one we're supposed to find.
0.53.
Okay, were you finding
Value
this, or you are finding the 0.7, the one that you're talking about?
Yes, the 0.702.
0.702. So you're saying you're getting
Yes.
Is the value of
0.7019.
0.53.
0.52.
53.
53. Okay. Is that what you're getting?
Mm.
0.53. Then what do you do? Okay, that looks like a correct value. Then what do you do? Remember, Z is what? Is X minus mu over what? Over that. Huh? Z in this case, X is our expected, which is our height. Huh? Clearly. So it tells you that height is simply equal to your whatever standard deviation, okay, multiplied by Z like this, huh? Plus what? Are we getting there? Plus our expected mean. Clear now? So you're saying 0.53 is your Z value multiplied by, what is the standard deviation? 12, huh? Plus mean is 40. What do you get?
46.36.
46.36,
36.
which gives you 46.4. Okay. Now, these are the nice tricky questions. Now, a fair three-sided spinner has three sides numbered 1, 2, 3. A five-sided spinner has sides numbered 1, 1, 1, 2, 2, 3. Both spinners are spun once. Each spinner, the number on the side, each spinner, comma, the number on the side on which its length is noted, the random distribution or the random variable X is the larger of the two numbers if they are different. And what I would suggest from this, from O level, you draw this table. So you know that you can say first spinner here. I'll just call it my first one. I would rather use this one. So it's 1, 1, 2, 2. So the first thing is always to understand the question. I hope you have. Then the second spinner there, I can have it in the other column going down. So I've got a 1, a 2, and a 3. Yeah? So this is my second spinner, if I want to put it. So I hope you understood the question. Huh? The random variable X is the larger of the two numbers. Huh? So it means if I spin a 1 and a 1 and they are the same, and the common value 1 will be if they've got the same number, it's 1. Huh? 1 and a 1, I'm getting a 1. What if I spin and get a 2 and a 1? A 2, huh? Because I'm saying larger, the larger number, if they are different. If I spin a 2 and a 1, 2. If I spin and get a 3 and a 1, 3 is the larger number. 1 and a 2, 2, 2. 2 and the 2, they're the same number. The 3 is the large number. 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 Clear now? Easy. Not difficult. Make sense? That's what they're asking you. If the larger of the two numbers, okay, is the larger of the two numbers. If they are the same, then the same number. So probability of 3, how many 3s do we have? 1, 2, 3,
7.
4, 5, 6. What?
We
1,
have 7.
2, 3, 4, 5, 6, 7. Okay, you should not count. You don't count this, huh? Clear. So how many? 7. And so we don't count this. So it's a space of 15. So it's say we have proved that, huh? Because they'll see from the diagram. Are we together? Clear? Now draw a distribution. We talked about it under discrete. Huh? So x, then probability of x is equal to x. So what are our possible outcomes? We can have a 1, a 2, and a 3. Those are the only there. Look there. Are we together? How many 2s do we have? 1s do we have? 2 out of what? 15. Eh? 2 over 15. How many 2s do we have? 1, 2, 3, 4, 5, 6. 6 over 15. How many 7s? You said 3, 7 over 15. Everything should add up to 15. Clear? Makes sense? Or it doesn't make sense? Done. Then you get the marks for free. Now find what? Find E of x. So maybe let's go back and do that there. E of x and var of x. E of x, we know that. Huh? So E of x, if you forgot, we are simply saying 1 times that. Huh? So it's equal to 1 multiplied by 2 over 5 plus 2 multiplied by 6 over 15. That's how easy that is. Plus 3 multiplied by 7 over 15. Clear? Now the first one is 2 over 15. The next one is 12 over 15. The next one is 21 over 15. What do you get there? I would say recommend you to leave it as fractions. What's 2 plus 12 plus 21 from a calculator? What do you get? 35, huh?
Yes.
35 over 15. Which is as good as if you reduce it, I think it's 7 over 3. Now, var of x. If you use your formula booklet, it will tell you that var of x is what? Is E of x squared minus your expected mean squared, huh? Like this. So what I'm simply doing is I'm squaring this, multiplying, squaring that, multiplying. It's okay. So let's find that E of x squared first. So E of x squared is equal to 1 squared is simply, I'm picking from this probability. 1 squared is simply what? 1 multiplied by 2 over 15 plus 2 squared is what? 4 multiplied by 6 over 15 plus 3 squared is what? 9 multiplied by 7 over 15. Okay, like this. So there I get 2 over 15 plus 24 over 15 plus 63 over 15. What do you get? What's 2 plus 24 plus 63? What
89.
Okay, 89 over 15. Okay, like this. Then we said, so we said that, okay, 89 over 15. Okay, so we want to subtract what? That's the correct formula, I'm sure. So it will be 89 over, I don't have the booklet, minus this we haven't, okay, it's 7 over 3 squared, I'm sure. What do you get?
$18 over 5. For 3.6.
No, it's wrong. Did you do the correct thing? Yeah, calculator.
Oh, sorry, sir. That's not correct.
We'll simply turn 1 over. So it's 8.
It's 22 over 45, sir.
Yeah. 22 over 45.
45.
Clear now. Perfect answer. I would suggest you leave it like that. Okay, I hope it's clear with everyone there. And how to find var x. Now, a topic, or some don't like this topic, but it's a good topic now. Find the number of different ways. So it's always in the exams, I'm sure you have seen it now. Find the number of different ways in which 10 letters from the word summertime can be arranged so that there is an E at the beginning and an E at the end. An E at the beginning and an E. So these are fixed positions. Make sense? They don't change. So if they are fixed positions, how many letters are left there?
8.
8. Huh? And from those 8 letters, they can permit themselves how many times? 8 factorial.
8.
Divided by what? How many are the same?
2.
M, M, M. No, remember the E is fixed here. We can't include it.
Yeah.
So it's only the M that is how do you that? That will, so we divided by 3 what? Factorial. Clear? I hope it makes sense for everyone.
So do we not multiply by 2 factorial because the e's swap each other?
Why do you say
Like they can,
the E?
because there's 2 e's, so can't they be on both sides?
They're at the ends.
Yes. So like, okay, what I'm saying is like, since there's 2 e's, right, 2 individual e's, can't, okay, E1 and E2, can't E2 also be at the beginning at some point? So don't you also multiply?
Find the number of different ways in the 10-letter word summertime can be arranged so that there is an E. There's always an E at the end and at the beginning. So you're saying E1 and E2. But but you see, they don't change what's in between.
Yes.
No, we don't multiply by 2.
Okay.
Clear now? So what's the correct answer there? 6,000 what? 720. Permutations and combinations. So you should be able to tell if you see a question that this is a permutation, this is a now, you see now, find the number of different ways in which the 10-letter word summertime can be arranged so that the E's are not, this is a tricky question, huh? The E's are not together. What do we do? Let's see, what do you think? That is a very tricky question. The E's are not together. What we looked at when we did the lesson, we talked about when the E's are together. Yes, what did you do?
I think first we would have to find the number of total ways in which it can be arranged, and then
minus,
and then minus the number of ways when they are together.
E's are together. Correct. E's are together. Clear now. So what are the total ways for this? Is 10 what? So let's do that. Total possible ways is 10 factorial divided by what? M's, we have how many M's together? That reduces our permutation, 3. We have how many E's together? 2 of them, 2 factorial, like that. Clear, no? From that lesson we did there. And what do you get?
302,400.
302,400. 2,400. Now let's talk when the e's are together. You remember I showed you last time that you combine them. So when the e's are together, there you treat them as one. That's what you said. Huh? Then you have the rest of the other letters. How many would they be?
9 or 8.
There will be 8. Huh? But I'm saying this, I'm also treating this as 1. Huh? Remember?
Yes.
And so that would be 9 what? 9 factorial. Divided by what? From that combination, what do I have? I have m's that are going to reduce my what? When these 8 are permitting themselves. Huh? Are we together there? So divided by 3 factorial.
Times 2 factorial, sir.
Why it has 2 factorial?
Because in this case, when we have the 2 e's together, the 2 e's also arrange themselves times 2 factorial.
I talked about the other day. I even gave you an example. I said when it's like that, I think someone asked the question and we were arguing. So when you do that, if it was for example, if it was T and E together, that's when we say times 2 factorial. Are we together? When they are different. When they are the same, we don't say times 2 factorial. Are we together? Clear now?
Yes, sir.
So
yes,
get that difference. If there were 2 different letters, then we say times 2 factorial. So what do you get there? Use your calculators. What do you get? Should get
60,480.
Yes. Then we subtract, like what you said. Judith, are you there? Very quiet. Then when we subtract, what do you get?
$241,920.
Okay. Clear? No. So selections, combinations. 4 letters are selected from 10 letters of the word summertime. Find the number of different selections, so those combinations. If 4 letters must include 1 M and exactly, or at least 1 M and exactly 1 E. So what do you do? Combinations and permutations.
I think you can sort of do it individually. So to make sure that you have the M and the E.
Yes.
So you would say. So you'd say 3 choose 1 multiplied by 2 choose 1 for the E, and then you subtract.
I get your point, but I would suggest list the possible combinations first.
Okay.
What are the possible combinations?
You can have 1 M.
Yes, 1 M. Huh? So
Yes.
can you have 1 M? We always must always have 1 E. Yeah? Yes. So we can have an E, M, then the rest of the other 2 from the other. Make sense? Then what else?
1 E, 2 M's, and then
1 E, M, M, then the other one. Then what else?
And then you can also have 1 E and then 3 M's.
1 E, M, M, M. Correct. See that? Those are the. So there. What was that?
That would be 2 choose 1 multiplied by 3 choose 1. That's 5. And then multiply by 5 choose 2.
You're saying 3?
Right?
No, sir.
3
I'm
choose 1,
saying,
I think.
What did
I'm
you?
saying, I'm
Yes.
saying it's 8 choose 2 times 7 choose 1 times 6 choose 0.
You're saying 7. Choose. Okay, let's see what.
I'm saying 8 choose 2
Mhm.
times 7 choose 1 times 6 choose 0.
And what do you get from that if you do that? I want to see a logic. I get what you're trying to do.
196.
Do you agree with him there?
No, I don't.
Yes.
No.
So what are you suggesting?
Okay, I'm suggesting you say, so you do it individually according to
Yes.
what you have over there.
Yes.
So you say, for the ease, you say, there's 2 e's, so you say 2 choose 1. And then since there's 3 m's,
You're saying there are
you
3
say
E's from this, huh? So you're saying for the first
there's
one, we
2
are
e's.
picking from 3. Yes, so you're saying 3, choose 1. That's what you're saying.
Okay.
Multiply by what?
There's two e's thing is 2 choose 1 for the e's. And then it's,
Oh, sorry, yes. 2, choose 1, yes.
yes.
Then for the
And
M?
then it's 3 choose 1 for the m's. And then since there's 10 letters, you subtract the 2 plus 3, and then you get 5. So it's 5 choose 2 for the remaining letters.
5, choose 2.
And then for the next one, is it correct or should I continue?
Oh, it's not correct. You have an idea.
Why?
We ignore this combination here. This, because this is like, remember, it's static. Huh? So we ignore this. We concentrate with the remainder. The remainder is 5 choose what? 5 choose 2.
Choose
How to get
2.
that there? I think
Yes.
we covered that question the other day. So it's actually 5 choose 2. Making sense now?
Yes.
Then for the next one, let's do the same way you have done. It will be what?
5 choose 1.
Yes, 5 choose 1. And for the last one,
It's 5 choose 0.
5 choose 0. Hope it's now making sense now. And this should give you 10 from maths. This gives you 5, and that gives you 1. So if we add all that, you get what? 16 ways. Clear now?
Yes.
Now, by the way, I'm sure you've done binomial distribution. It's in your syllabus. Have you done that, all of you? Those that are writing? It's in your
Yes.
syllabus, huh? And
Yes, sir.
when does something qualify for conditions for binomial distribution? When we've got an exact what? Probability.
Probability.
We've got a fixed number of trials. Huh? The probability is of success is independent. Huh? Altogether, it remains the same. Huh? Clear then? Now, so if for a question like this, on a given day, the probability that Moana passes her friend messages, her friend Pasha is 0.2. So it's a fixed probability on any given day. Yeah? Okay. Now we've got also a fixed number of trials. Huh? So it follows that X follows a binomial distribution with NP. N is the number of fixed number of trials. P is the probability. So this follows a binomial distribution. What is our probability? 0.2. And what is, sorry, the number of trials? Okay, sorry about that. So there is 12, then probability 0.72. And what do you want to find from the question? No more than what?
Then 9.
What does that mean? It means probability of what?
Less than 9.
Less than or equal to 9.
Less than or equal to, not only less than or equal to 9.
Okay.
Now, which means I'm going to say probability of 9 plus probability of, but that's longer. So this is also the same as what? 1 minus probability of what? Of x being greater than 9.
9.
Which means 1 minus, in brackets, probability of x is equal to 10 plus probability of x is equal to 11 plus probability of x is equal to 12. Clear now? Okay. Which means now this is easy. So this is 1 minus in brackets. Now when we are doing that, I'm sure you know that from the formula booklet you have it, the formula there is now the number for this n. Choose, what are we choosing here? 10.
10.
Multiply by your 0.7 to your probability, your p, raised to the power of 10. Plus, so we always find q is 1 minus p, which means q here is 1 minus 0. It's not probability of not messaging. So what is that? It's 0.28. So there, so it's multiplied by 0.28 to the power of what? If we subtract 10 from 12, it's what? 2,
2.
like this. Plus 12 choose 11, 0.72 to the power of 11 multiplied by 0.28 to the power of 1, if you want to put, or just 0. Plus, lastly, 12 choose 12, multiplied by 0.72 to the power of 12. That other to the power of 0, you ignore it like this. So do that in your calculator. That's all you're doing. 1 minus that, Maxine, let's do that. These are our calculators. And we should get our answer. Between now and the exams, we do main question papers.
.696.
That's correct. 0.696. Now let's go to the next one. Moana messages Pasha on January 5. Find the probability that the next day she will message a friend is January what? So what do you do? 1 mark the exchange is January 5. So it means from January 2, January 3, January 4, she is not messaging a what? A friend. What's the probability of not messaging? We talked about it. It's Q. It's 0.28. The probability of messaging, we said it's 0.72. So if so on January 2, she's not messaging. So it's 0.28. How many days does she not message? January 2, January 3, January 4. Makes sense? Multiplied, now she messages on January 5, which is 0.72. That's how easy that is. So what do you get?
0.0158.
0.0158. Okay. Now the next part. Use an approximation use an approximation to find the probability. So we are doing a normal approximation, no, normalizing a binomial, because when n is large, you can't use, normally when n is above 30, you can't, altogether, when it distorts your binomial distribution. Okay, so you do a normal approximation to binomial distribution. So if I have n following a binomial distribution np, like what you said, if we are now doing the normal approximation, what is our mu? How do you find mu? Mu, mean, for your normal distribution is np. If you didn't know that, you multiply these two. N, sorry, the number of times. So this n becomes what? It's no longer, remember it was 12, it's no longer 12, it's 100. Clear now? So I'm saying n follows a binomial distribution. Now it's, okay, binomial is now 100. Probability does not change, 0.72. But now we're saying mu is now that. So what is 100 times 0.72? What do you get? So that we normalize it. So it's
72.
72, yes, like this. Then the variance. Who knows what the variance is? Variance is NPQ.
NPQ.
So which is 100 times 0.72 times 0.28. What do you get?
You get 20.16.
20.16. So now your n now follows a normal distribution with 72, then 20.16, like that. Clear now? Of course, for standard deviation, we have to do the square root of that. Now, that's true. Now, so what we want, let's go back to the question now. We've almost, now one probability of less than or fewer than probability that x is less than 64. So before we do this, because we are doing an approximation, what do you do? What's the next thing? You need to know what is called
continuity
correction. Continuity correction. Continuity correction. So maybe for those that forget, I'll simply give you something maybe you need to write down. If P, probability of X is equal to A, if we're doing a continuity correction, then that will give us probability of X. So the probability of, because I'm saying is equal to A, so it's probability of A minus 0.5 less than X. X less than A plus 0.5. Are we together? Then if X is greater than or equal to A, like this, so we subtract. So it's equal to probability of X being greater than A minus 0.5. Are we together? Now, if probability of X is greater than A, that will be equal to probability of X being greater than A minus the same 0.5. I'm just writing so that you know, you always remember this. So if I have probability of X being less than or equal to, I'm sure you see this to be the opposite. It will be probability of X less than A plus 0.5. Clear? So if I have a probability of X being less than A, it's equal to probability of X minus A plus 0.5. So if we go to this, it's less than, so it will be equal to probability of X less than 64 plus 0.5 gives us 64.5. So probability of X is less than 64.5. Clear now? Then we now normalize it. So it's probability of Z being less than 64.5 minus 72. I'm sure you can tell mean is 72 there. Minus 72 divided by.
So isn't it 63.5, sir?
Which one?
Isn't it 60? Z minus Z is less than 63.5 minus 72.
Did I say less than? What did I give you? Did I give you a wrong continuity correction? You said Z is less than what? 65 point?
63.5, sir.
Mm-hmm. Or you're saying we subtract?
Yes, sir.
Oh, yes. Why did I get... Oh, okay. I mixed up things there. Okay. No, we should subtract. I don't know how I mixed up things there. Okay, if it's less than, we subtract. I totally messed up the table there. If it's we subtract, yes, that's correct. We're supposed to subtract. If it's less than, we subtract. So this is not correct. We subtract there. So this, if we subtract, what do you get? 63.5. Huh? That was a mistake there. So its probability of Z is less than 63.5 minus 72, which is our mean, divided by the square root of that. Remember, this is not standard deviation, this is variance. What do you get? Z
Negative 1.89.
1.89. Now we know that we can't get negative, remember? Negative 1.89. Negative 1.89. We can't get this. We do this positive one, 1.89. It will be the same. So this is the same as probability of Z being greater than 1.89. And from if it's greater, it's 1 minus. So this is 1 minus probability of Z less than 1.89, which is 1 minus phi of 1.89. What is phi of 1.89? From your, let's use our tables now. Maxime, you have been very quiet. You have been in the lesson.
So 0.9706.
0.9706. Do you agree with him? The guys that are using the tables, but I'm sure it's easy to go to 1.89. Then if we subtract, what do you get?
0.0294.
0.0294. Clear now. You find that if you go maybe in your, you were using a table or your calculator?
The table.
The table. You find that in the marking scheme they have 0.092 because I think they use more of the calculator than the actual table. The calculator is more precise, but anyway, they know that you are using what? You are using the table, they will mark that as correctly. Because your calculator gives you more precise. Your calculator can do tables, huh? Maybe I'll send on the group. I said that was, you should know also how to use your calculator, especially the Casio calculator, to find these values. Okay, we'll see you during the next, before now, and I'll send the paper. So can you do the paper, submit the paper? Well, only a few are submitting, then I'll mark it. I'm going to send the paper. I want everyone to do the paper before, try to submit before Wednesday, the full paper, so that at least I have know where you are. Okay. Have a nice weekend.
Thank you, sir.
You're welcome.
Thank you.
Thank you.